A square-based pyramid has a slant height approximately 10.77 feet and an altitude of 10 feet. Find the lateral surface area first off. Rather than trying to do this stuff without any sort of illustration, it's a good idea to just kind of draw a little picture. I should probably make these dashed because they're kind of hidden. So that's what my pyramid looks like. The height right here. In total, this is 10 feet high. Get rid of that. There's too much stuff written in there already. In total, this is 10 feet high. And the slant height, this distance right here, from the apex along the face down to here, is 10.77 feet. Okay, so first off, I want to find the lateral surface area. According to my formula, this is 1/2 times the perimeter of the base times the slant height, not h, but s. So we get 1/2. I guess I should figure out the perimeter of the base. Each of these are 8 feet. Let me draw the base here. It's pretty basic because it's a square-based pyramid, so it's 8 feet by 8 feet. Actually, all of these would be measured 8 feet. I'm just doing them because I'm talking about the perimeter here. The distance around the outside of this square would be 8 plus 8 plus 8 plus 8, which is 32. And the slant height of this pyramid was 10.77. So the lateral surface area of this pyramid, 0.5 times 32 times 10.77, is 172.32. The total surface area would be the lateral surface area plus the area of the base. Well, I guess I should probably specify down here. The perimeter was 32 feet. The area of the base, 8 times 8, is 64 square feet. So the total surface area would end up being my lateral surface area, which was 172.32. Plus the area of my base, which is 64. We end up getting 172.32. I already have that entered in there. Add that to 64, we get 236.32. This would be in square feet. If I wanted to find the total volume, the volume here, V, is equal to the area of the base, 1/3 the area of the base, rather, times the height. This is not the slant height, this is actually the height of this particular pyramid. We already have the area of the base, which was 64, and we have the height, which is 10, so 1/3 times 64 times 10, which gives me 213.3 repeating. And this would be measured in cubic feet. Find the lateral surface area and volume for this triangular pyramid. We're told the base is an equilateral triangle. And then I want to round this to the nearest whole unit. Okay, so first off, the lateral surface area. We're generally calling that L. Since we're dealing with a pyramid, we know the lateral surface area is 1/2 times the perimeter of the base times the slant height. So I'm just pulling that directly from a formula. So the perimeter of the base, let's talk about the base here. This is an equilateral triangle, it says, so that means this distance is 16, that's 16, and this is 16. The perimeter here would then be 16 plus 16 plus 16, which is 48. This is in centimeters. And the area of the base, I'm just going to go ahead and figure that out now, because I'm probably, well, yeah, whatever, I'm probably going to need it. This will be 0.433 times the side length squared, which we called a squared. Again, this is pulled directly from one of those formulas. Since this is an equilateral triangle, figuring out the area of this equilateral triangle is pretty straightforward. 0.433 times 16 squared is 110.848. You'll notice I'm not rounding that to the nearest unit yet. I want to wait until the very end of the problem to do any sort of rounding, because I don't want to introduce error any earlier than necessary. Alright, so in any case, we're in the middle of figuring out what the lateral surface area is here, so 1/2 times the perimeter of the base, which was 48, times the slant height, which is, it looks like 36.3 centimeters. 36.3. Multiply that stuff together. 0.5 times 48 times 36.3, which gives me 871.2. I was told to round everything to the nearest whole unit. Let's see, this was in square centimeters, rather, which we would round off to 871 square centimeters. So that's the lateral surface area here. We're also trying to find the volume of this triangular pyramid. Volume is in general 1/3 times the area of the base times the height. So 1/3, I already figured out the area of the base, which is 110.848. And the height was not given to us. Oh, here it is. It's right there. 36 centimeters. I didn't see it for a second. 36. So let me multiply these numbers together. 1 divided by 3 times 110.848 times 36, which gives me 1330.176. And again, I'll round this off to the nearest whole unit because that's what it calls for. So this will be 1330, 1330, and this would be cubic centimeters. Quick note, sometimes cubic centimeters are called cc's. If you're talking about the medical field, they usually call those cc's. Nice thing about the metric system is that's the exact same as 1 milliliter. Makes the unit conversions extremely easy. Alright, find the total surface area of the hexagonal pyramid shown. Round to 3 significant digits. Alright, we're trying to find the total surface area. We call this S, which is in general going to be the lateral surface area plus the area of the base. So, you know, we have the however many sides we have, plus the area of the base. I should probably start by drawing my base of this pyramid. It looks to me like this is, I think it's probably reasonable to assume that this is a regular hexagon. So this 3.5 yards, everything is in yards, okay. This 3.5 yards right here would be the same length for all of these sides. All the sides of this hexagon. And so the perimeter would end up being, well, 6 of those. 6 times 3.5 is 21. The slant height, so the total surface area, I'm going to need my lateral surface area, so let me take a moment and figure that out. The lateral surface area is 1/2 times the perimeter times the slant height. So 1/2 times, I already figured out the perimeter of my base, that's 21. The slant height, it looks like it says right here, is 12.38 approximately. And so this will give me 0.5 times 21 times 12.38, which is 129.99. So that's my lateral surface area. The area of the base, alright, well this is a hexagon. Let's see, the area of the hexagon, if I recall, is 2.598. I have to go look this up. A squared. Yeah, that's correct. I'm just pulling that again directly from my formula sheet. So the area of the hexagon is 2.598 a squared. A is the side length of the hexagon. So that means the area of this would be, I mean, this is approximate, but let's see. Where's my calculator? There. 2.598 times 3.5 times 3.5, which gives me 31.8255. That's the area of my hexagon. 31.8255. So that means my total surface area, now I can actually go back to the original formula here, is going to be 129.99 plus 31 rather. 31.8255. So add these up. We end up getting 161.8155. The last thing I'll do here is round this to the appropriate place. It says round to the 3 significant digits. We have 1, 2, 3. It looks like that'll be rounded to the nearest whole number. So it'll be 162, and my units here are in cubic yards. No, square yards. We're talking about a lateral total surface area. So the total surface area is 162 square yards.